Alright, part 4 on our series on this function problem that we got off Facebook. And again, if you haven't seen the first 3 parts, please go back and watch them first. So we've shown how to graph our function. That we have a plus n times b plus n, if you can see the times, b plus n, and all that plus a plus n. So, is this function continuous? Meaning, every time you put a number in this column, are you going to get a number in that column? So as you can see, I've kind of gone back and worked out some stuff on the other side of 0. -1, -2. So it did produce 2 more ordered pairs. So it tells us at 0, this function is continuous. And the truth is, this function is continuous. Anytime you put in x, you're going to get a y. And usually in spot ones, they're not going to be continuous because usually they have some form of division in them where you can get 0 on the bottom and you can't divide by 0, and then the function winds up not being continuous at that point. Since this one doesn't have any division or subtraction or anything where we could wind up with a division by 0 or something that won't give us an answer, you can glance at it and know it's going to be continuous. But we can show it's continuous. We're going to plot our next points that we have on the other side of our x is 0. So x of -1, or f of -1, we'll put -1 in, you come out with 0 for your y. So this isn't going up or down, this is only going left or right. And so it's actually going to wind up right about there. So when we put -2 in for our n, we get -3 out of it. So we gotta go -2 here, -3 there, and kind of continue our line like that. Now, this line should be reflexive, meaning as you see it kind of making this gentle slope up here, it most likely would kind of make that gentle slope like this on that side as well. But as you can see, the line is solid and unbroken here as we pass the origin, the 0, 0 point on our graph. So we know that we can say that at 0, this function is continuous. Like I said, you could guess that it might break somewhere if you put in a large enough number, a large enough n in right here. So if you put a large enough x number in for your n, it might break, but most likely not, because I said you don't really have much of anywhere that you're going to get a consistent 0 or something where like a division by 0. So that is how to determine if your function is continuous at 0, going by either the graph or the table. Again, I know these last 2 were pretty quick, pretty short. The explanation was not as in-depth. But again, always, if you have any questions, you can just put them in the comment. I'll do my best to get to them and answer them.